All right, welcome to the first week presentation. So we're going to do an introduction here today with analytics for security and intelligence. Talk about the week 1 material. As I mentioned in the presentations, I'm gonna talk quickly through some of this stuff. I don't want to keep you on these long videos, but I want to sort of point out some of the key areas and then let you spend some time digging into it further as we go forward. Course outline. We'll talk a little bit about what we're going to do in the course. A bit into this. We're going to talk about intelligence, what it means to actually be an analyst. We'll go over some of the key participants, some of the key players that you hear about a lot from an analysis standpoint, and then some characteristics of intelligence and some issues that, when we think about data analytics, you can think about the technology. But when you think about for security intelligence, there's some other issues that really come into play that we need to start thinking through and make sure we're accounting for. So intelligence, definition here. It's the act of understanding. It's comprehension, information, news. For our purposes, a lot of times we consider it sort of from mainline verbiage to be information concerning an enemy or possible enemy, or an agency engaged in obtaining such information would be called an intelligence agency. So either way, the end goal of all intelligence really is to make better decisions. That's what the government's looking for with intelligence agencies. That's what they're trying to get with the intelligence that they gather. So what do they get for defense and security? There's a lot of different kinds. There's human capital intelligence. This is, spy work kinds of stuff. What do we know from people? What can we tell from financial systems? What can we tell from the internet, from cyber patterns? What do we know from a strategic standpoint? There's supply chain, what's being purchased, what's going where, and there's technical intelligence that we'll get into a lot when we talk about collection, the different types of intelligence, measurement intelligence, electronic intelligence, those kinds of things. All of that really informs decision making. So you're probably familiar with the OODA Loop, the observe, orient, decide, and act. Every government makes these decisions. Everyone in a tactical situation or strategic decision making situation uses this sort of loop. We all do. We're driving down the street. We're observing and we're reacting to that. What we want to do is in all the different kinds of decision processes there on the left, whether it be mergers and acquisitions for companies or combat or arms negotiations, there's all this kind of collect the data, do analysis, decide, make some recommendation, and act on it. The quicker we can do that, and the more effectively we can do that, the faster we speed that cycle. So what does an analyst do? Basically, the analyst does the examination of all the complex elements of a system and their relationships in order to make better decisions and inform whoever's in that OODA loop what the right appropriate course of action is as quick as possible so they can take that action around them to be what they want it to be. So what is an analyst specifically? Well, we've got some organizations listed here, but I won't read them all, but you should spend some time with these. DIA, CIA, NSA, NRO, a lot of these will constitute what we call the IC, or the intelligence community within the government. And each one has a little bit different mission, a lot of overlap, obviously, a lot of stovepipes within those as well, which can be problematic, but can also allow for greater security. So, understand the missions there and the kind of sources that we use and who they serve. And then in other vocations, think about the fact that there's other, like insurance companies, financial analysts, marketing, everyone does intelligence in some way. And they use analysts to take that intelligence and do something smart with it. We can learn from that, whether that's from commercial practices or in defense itself. So what is analytics per se? So we've talked about analysis. What is analytics? Generally refers to analysis but executed over very large unstructured data sets. So when we talk about analytics, usually what people are going to be talking about is big data. They apply that big data term into this. The data itself is going to guide the information flow in analytics, not necessarily us going in and finding every specific thing that we know we need to find. A lot of times the data will tell us what it has to say. Trends will emerge out of the data, sort of unexpectedly sometimes. And there's really different layers. There's diagnostic analytics, so we say something happened, look at all the big data and see what caused it. There's descriptive that says, here's all this data, what does it mean to me? There's predictive that says, I know what it means, now can I apply algorithms across this data to predict what's going to happen in the future? And prognostic is machine learning that basically says, if I can predict these things in the future, then I should automatically be telling myself what to do rather than waiting and doing that work myself. So now we've sort of introduced that. Let's go through the agenda. We're going to be talking about next week collection specifically. How do we go and get all this data that's going to be useful for analytics? And then we'll talk about analysis methods and types. What do we do with it? Then talk about specifically big data. What does that bring to the table, and how do we leverage that? Then if we get all that data, how are we actually making sure it's the right data, and how we manage that? And then once we get all these analysis, how do we present it in a way that's going to make sense to the listener and to whoever it is we're serving? A couple of special topics there. We might not get to the business intelligence, but I know we'll talk specifically about cyber because it has an important role in all of this. There are issues that we need to be keeping in mind as we go through defense for security and intelligence. One is that, we are dealing in a political environment. So it's worse than any company that you might be doing analytics for. There are different branches of the services with different goals and different agendas and power structures. There are different agencies. There's the layers of federal, state, and local that don't always communicate or have the means really to communicate well. There's privacy issues we have to be concerned with. There's Title 10 and Title 50 that says some people can make investments to go do things outside of the U.S. Some people can do stuff inside. Some are just strictly intelligence. Some would be intelligence focused on warfighting activities. Those differences are constitutional, and they drive a lot of the investment, and they force a lot of the separation that frankly can cause a problem when we're trying to do fusion or prevent terrorist attacks. There's a technical architecture. Anytime you come up with a great idea, you got to implement it somehow. And there's huge architectures out there for all this stuff that need to be integrated. They're constantly moving. There's classification issues, right? So once we get data in and it's classified, each service has its own classification, each program does, each agency, and there are some people that use that basically to their advantage, so we got to keep that in mind. Then when we get to presentation, what we want to talk about there is, well, how confident are we in the analysis? Would you bet your career on it? Are you going to bet people's lives on it? These are the kinds of things that if we're going to say something, how do we communicate? We'll never know 100%, but we got to be able to come up with something that communicates that we know well enough that we are making a recommendation as to a particular decision that could be made. Who sees the analysis? If we show this analysis, is it going to betray our sources? Think about the Walkers in the U.S. Navy, what they did just by using data, by letting this data come out. The Russians were able to figure out that we had some access into some of their communication lines. This is the kind of thing we need to be thinking about when we're doing a presentation. Can we present all the information effectively without confusing it? So go back to our intelligence flow. You've got ingest and processing. You've got analysis production. You've got exploitation and dissemination, the presentation of it there on the bottom. And all throughout this, there's issues we need to worry about from a data integrity standpoint. Are we getting the right stuff? To analysis tools, do we have the right capabilities to really answer these questions? To reporting, are we presenting the analysis correctly and in a way that makes sense and allows people to make decisions on it? And then those recommendations will flow out of that. It just continues to loop, just like the OODA loop. Our analysis, when we talk about analysis, there's a number of different types. There's statistics, there's text and data mining, and we'll go into all of these. But statistics is just basically stuff we've been doing for decades, right? You're looking at trends and patterns in the numbers. Text and data mining means there's things that are being written that we can garner information about by how people are communicating. Model management and deployment. If we create these algorithms, what makes sense to deploy in different environments? How do you use those curves and math to sort of forecast things? Forecasting, econometrics, optimization, all of these are sort of analysis techniques. Data analytics is going to take all those existing analytics techniques and apply them across large data sets and or add historical data visibility to them. So a lot of big data is this years and years of data we could never get access to before because we just didn't have the technical means to hold all that stuff at one time. Now you can see these huge trends. You can load it all up and see huge trends that are happening over years of data that we just couldn't have access to in the past. Now the technology allows us to do that. So it's current in combination with historical data. Also can validate that analysis. Any analysis that you come up with or recommendations, you can use big data to validate that across real activity. If this is what we think happens, look in the past. Did we see this happen in the past? Data integrity is then discussion of the data itself. Is it the right data? Is it quality? Right? Are we getting garbage? The old saying that garbage in, garbage out is true with data analytics as well. You want to do inspection. You want to look at the quality. You can go through and score and use machine learning to actually fix data that looks to be problematic, depending on what else is there in the data. That's cleansing and enrichment. You can synchronize sources. What are the time frames that these things were recorded on? Do we need to sync up the times so that when you see patterns, they actually make sense in terms of temporal space? And then just, all that management of data, how do you keep that and manage it in a way that doesn't get corrupted over time? And then finally, reporting. There's two big things. We got query and analysis, which is just search capabilities. And then we got our visuals, which are our integrated analytics. If we're going to report on something or make it available, then we've got to make it tagged. We've got to make it searchable. So here's what we found. Here are the kinds of text data you want to go after. Give them fuzzy logic allows people to say, I think people would be talking about these kinds of things. Now tell me all the instances of this happened in the past. Those are kinds of things that go into query and search. Then once you know the data and you've sort of structured it, you know kind of how this data lays out, you do these integrated analytics that tell you over time, this is the number of hits against a particular network. These are the number of times number of hours that were spent maintaining certain activities, number of parts that a certain military has purchased from a supplier over a period of time. All those things might tell us things about their activity or their certain posture. Those are the kinds of things that we see out of reporting. And it can translate itself in different ways. Let's keep in mind that this is not a perfect science. Examples here of the two big competitors, Airbus and Boeing, right? Both of them had challenges they did deal with in the 2000s and then 2010s. In the 2000s, they were all looking at where to go with new airplanes. They had the access to the same data. They probably had the same results in terms of where they thought the business was going to go. Boeing interpreted it to be, hey, we need to have a fuel-efficient plane. Airbus said, we need to have big planes that can carry a lot of people over long routes. Boeing made the right decision. Their investment paid off. On the same time, a decade later, they looked at their small planes and said, well, do we want to invest in a new one or do we want to wait? And they had access, again, same data, possibly same results, wound up with the same interpretation. They just re-engined the existing planes. Both are multi-billion-dollar decisions that have the stakes of the company ride on these things, but their results can be different based on how the analysts effectively use that data. There's unique things as well. How do we go from unstructured to structured data to find terrorists? You look at there's this story in Freakonomics, if you happen to get a chance to read that book, where terrorists don't buy life insurance, and that's the method that they go to kind of find a formula to find people who are up to no good, basically by looking at who's buying insurance, who's making investments in banks, and kind of combining some of this stuff together. So that's the kind of thing. What pieces of data can you gather on somebody to really make a decision or to help you to sort out people that you might be of interest with? How do you find terrorists from those big data patterns in social media or in video surveillance? Certain activities, certain patterns of movement, now that you can identify people using image processing. How do you find pocket road? This was the initial GIS instance was a police department, I think in Pennsylvania, that just used GIS to find pocket roaders by looking at where the rivers combined and where sort of the soil was. Can you defeat a superpower without firing a shot just by investments? Those are the kinds of things that can be unique, but analytics kind of play to all that. And then finally, presentation. You got to be able to communicate this stuff effectively. You got to talk in terms of what your audience cares about. Is it lives? Is it dollars? Is it how do we use these resources the best way to make the most effective investments? These are all things that, if knowing what your audience is trying to get at, you got to shape the analytics presentation to feed that. And then finally, you get your details. So we know what an analyst is. We know what analysis is. We've got big data analysis. We know what that is. We kind of know what it's used for. It's used for make decisions. An analyst's most common response is, well, it depends. That isn't good enough. We've got to be able to give good recommendations presented well and effectively in order for leaders to make decisions. So that's what we're going to do in this course. We're going to discuss the challenges in this presentation and prepare you to thoughtfully engage with analytics using tools at our disposal and that we have, and give you some insight on how to communicate all these results effectively to your customer.